Hey guys, in this series of videos that I'm going to cover, I'm going to introduce you to something called a abstract class. And what it is exactly, well, we'll get into that in future videos, but it first starts out with the base class. And instead of using rectangle and cube, my plan for this is to use triangle as kind of the two-dimensional shape. And then we're going to create a class called Shape3D, which is going to be our abstract class. And then we're going to have Pyramid, that's going to act as our three-dimensional shape for triangle, just like cube was the three-dimensional shape for rectangle. So why don't we get started? I already pre-wrote a main for us to take a look at. It's going to include triangle.hpp. And what's the difference between HPP and H? For header files, and there really isn't one really in the context of C++. For C, you want to use .h, however for C++, you can use .h or .hpp. I personally deal with a mixture of C only code and C++ code, and sometimes they mingle with each other. Personally, it's important to have my header files distinctly made between what's a header file for C and what's a header file for C++. So I personally like to use HPP files, but using a .h file is perfectly fine. Anyways, moving forward, I'm going to create 3 variables of triangle, 1 without parameters and 2 with 2 parameters. My constructor, how I'm going to set it up, is essentially initializing both of the attributes to 1. So these 2 declarations for T1 and T2, they are the same. So my plan is to overload the double equals operator, the not equals operator, and the double angle brackets operator, as well as the equals operator, so that way we can assign values to triangle and kind of make the use of triangle more intuitive. But as I talk about that, let's talk about triangle.hpp. I already have the declaration here. So how is it going to start? Well, since it is going to be a base class, well, I need to have my protected. I want the base and the height, as well as my area, which is going to be a float, as well as my perimeter, which is also going to be a float. I want these all to be protected because I want potential classes that will inherit from this class to be able to use them kind of as their own. So here I'll continue with the constructors. I have one, an unparameterized constructor, which is going to be setting all of the attributes to 1. Well, the height and base, the other attributes will adjust for accordingly. And then here I'm going to have triangle, and I'm going to take a reference to a T. And then since this is a base class, I'm going to have a virtual destructor just to practice good base practices. And then, well, I'm going to have my getters, right, which is going to be base. You gotta put the constant there as well as the height with the const. And I also want to return area with the const as well as perimeter. So something else that I'm going to do, and actually let me separate this. This is going to be the getters. And then here I'm going to have the setters. Right, so what I'm going to do is that I'm going to make my setters virtual. Why am I doing this now? Well, the quick answer is that I realized when I created my other classes that when I call these setters, because I have variables that are dependent on these variables, namely these 2 methods that I have here, calculate area as well as calculate perimeter. These methods, they depend on my 2 attributes here, right? Set base and set height. So when I go into the 3rd dimension, what's going to happen is that, well, I still need these setters to work. I mean, I still want to, when I call these setters, I want to be able to update any other attributes that I may or may not have. So more specifically, when in the future, when triangle is the base class for my pyramid class, what's going to happen is that I want to overload my setters, so that way when I call set base and set height, I can update the oops, I spelled operator wrong. I can update, the new attributes in the future, right? Attributes that would be associated with this third dimensional shape would be, volume and surface area. So as I'd like to update volume and surface area, I like to do so through the setters. And so what's going to happen? A lot of triangle is going to be similar to rectangle. Actually, triangle and rectangle are very similar. I think really the only thing that's really going to be new is that I'm overloading the double equals operator and the not equals operator. Other than that, I have the same methods. The only thing that's going to be different is going to be, the calculation of area and perimeter. Can't forget the semicolon. But this is going to be what the header file looks like. Now that we have the header file defined, I need to go and do the pretty tough challenge of writing all this code for incorporating the triangle class. This is always such a tough part, just because, man, it's so much code to write, but it's good practice for me either way. So what's going to be special is that, well, my triangle is essentially going to look like this. I'm going to have this as my base. This as my base, and this vertical line is going to be my height. Right, so these slant lines, they really aren't going to have any value. However, I will need to calculate them when I go about calculating perimeter, but I'll get to that math eventually. Well, real soon. So I'm going to start off by initializing base and height to 1, and then, well, because my triangle is essentially, I'm creating my triangle in this manner where my height is going to be the line down the middle. The area was actually going to be simple. It's going to be the traditional way that we go about calculating area, which is 1/2 base times height. So 1 times 1 is going to be equal to 1 times 1/2 is 0.5. The thing that's going to be interesting is the perimeter, and that when I go about calculating the perimeter of the triangle, I need to calculate this slant, right? The hypotenuse, right? If we cut this triangle into two different triangles, the hypotenuse of the triangle. And it turns out if I have a triangle of height 1 and base 1, that the perimeter is going to be 3.23607. And yeah, that's kind of a long number, but that's alright. We're not going to do too much with it here. Here's just the default way of creating these values. So our parameterized constructor and our copy constructor is going to follow pretty much the same procedure as a rectangle class. And you can see that with here, initializing my attributes first, then calling my setters for the height and base, as well as for area and perimeter. And with the triangle copy constructor, just taking pretty much a copy of the input. This should look familiar, quite familiar to rectangle, and how I made that there. And then as well, I need to add my destructor, which is essentially going to be empty, just to keep things simple. Then I'll have my getters, and like the getters for the rectangle class, I simply return the attributes, and the setters should look quite similar to rectangle as well. However, here things are going to get a little bit differently, and well, actually, first let's talk about these setters. So set base and set height, these should look strangely familiar, as they are very similar to how we went about the setters for set length, and set width. And now we get to area. So area should, in theory, we'll say in theory, should be simple. It should be 1/2 times base times height. And actually, I'll put this in parentheses, although it is, that's alright. I'll put that in parentheses just to state my intentions. And then we'll have triangle, and then, ooh, this is going to be probably the toughest one, just because I need to calculate, I need to do like a hypotenuse calculation, because when I go up here, well, actually, let me write down the variable for it. So we'll have my hypotenuse. So I essentially need to square half of the base, and how I go about that was I have 0.5 times base times, right, because the idea is that I'm squaring this, 0.5 times the base, and then, because it's like what's Pythagorean Theorem, to calculate the hypotenuse, here is the a squared, and I need to go about the b squared, so I'll have height times height, simple enough, and then hypotenuse is going to be equal to the square root of itself as a variable. But now that I'm using the square root function, well, typically when I use square root, I need to include math.h. This is typically what I'd have to include, math.h. And I say typically because this is the C way of doing things. In C++, if I want to include the C math header file, what I do is that whatever C header file you have, you get rid of the .h and you put C in front of it. So instead of including math.h, I include C math. And this goes for other libraries too. You know, if you need to, instead of typing something like, you know, stdlib.h, you get rid of the .h and you put C in front of it. So C stdlib. Right, so just in case you need to use the functions there. For me, I just need to use C math. And again, that's because when I'm calculating the perimeter, I need to calculate, well, it's going to be the bottom base times this slant, right? But I only have the height here. So in order for me to calculate this slant, I need to use the Pythagorean theorem, where I need to essentially split this off into two different triangles. Here I'm going to calculate base, the base squared times the height squared, and that's going to, and I take the square root of this to get the slant, and I need to do that twice. So now that I can go down to the perimeter, I have that calculation of the slant, which is now hypotenuse. So my perimeter is going to be equal to, well, the base plus 2 times the hypotenuse. And that should be it for my perimeter. Operating the equals, double equals, and not equals should look somewhat familiar to rectangle. Here I kind of abuse my setter. I directly set the attribute equal to the input attribute, and then I call my setter. So here again, I get 3 birds with 1 stone, because with the setter I'm going to be calculating height as well as my area and my perimeter. And let me go up here. And oh man, I always forget this. I need to have calculate area as well as calculate perimeter here. And then these two I need to copy, paste right here. Okay, and now we're good. So I get my 3 birds with 1 stone. I'm going to have my triangle with my operator, my comparison operator, which is the double equals operator, and I'm going to be comparing triangle with, well, I'm going to be comparing the attributes of triangle with each other, which should look fairly similar to how I did it with rectangle. I don't remember if I did it with all 4 of the attributes of rectangle, but here for triangle, I'm just going to do with both of these attributes, all 4 of them. I personally think it's sufficient just to compare the base and the height. But just to be completely thorough, I'll be checking all attributes. And then with the not equals operator, I'm going to abuse the fact that I have the equals operator, and I'm just going to flip the logic. So lastly, we come down to the creation of our friend function with the operator. Oh man, I'm forgetting the A. There we go. Operator, so that we can print our class with stood C out. And this should look familiar because I essentially print with the rectangle I print the length, width, area, and perimeter, but now I'm printing the base, height, area, and perimeter. So why don't we go about testing our triangle class? I forgot to include IOStream, and let's go to, where is it? I think the calculation of hypotenuse here. Why is it complaining? So we have this. We have, yeah. Oh. That doesn't have it, and it's not supposed to. Oh man, there is errors. Okay, let's take a look at this. Oh, I see, because I think there's an error with the O stream. So I need to go to the header file, simply include IO stream, and I think that should fix it. Yeah. So now we'll run it, and bam, triangles 1 and 3 are not equal. Oh no, it doesn't say that the other ones are equal. That's probably because the floating point is not exactly correct. Dang it. So because perimeters afloat and it can be pretty wild from each other, what I'm actually going to do is that I'm going to get rid of it and actually end this too. I don't want to deal with the floating point precisions of both the area and the perimeter, so I'm just going to check if the base and the height are the same. Just because I don't want to deal with the arithmetic potential errors of like having my flow being initialized one way and having it calculated another way. But anyways, here's the result of our program. So it works. Yay. Ooh, that was quite long. But don't worry, for the next video we're going to create our abstract class, which is the most important part of this series. And then after we create our abstract class, we're going to create our pyramid class. And I gotta tell you, triangle does about 75% of the heavy lifting. When we create our pyramid class, we only need to override a bunch of methods, and it's pretty slick. I mean, we need to do our operator overloads, but that's the only like really original thing that comes from the pyramid class, and it's pretty slick because we're essentially getting two other classes, namely triangle, which we just created in this video, and shape 3D, which we'll create in the next video, and that pretty much makes pyramid our pyramid class. But anyways, I'll see you there.